So we continue now with the domain exercises. We got a few more to do here. Let's take a look at exercise 7. Find the domain of this function, x squared minus x minus 6 over x squared plus 3x minus 10. And we're looking for trouble, right? We're looking for values of x that could make trouble. And there are two kinds of trouble. We get trouble when we have x in the denominator. And we have trouble when we have square roots. So far we've seen those kind of trouble. In this problem, we have the x in the denominator situation. We don't have the square root trouble to worry about, right? We just have the x in the denominator. So we're going to apply kind of analysis, kind of like we did in exercise 5. So square root is not an issue in this problem, but in general, that's something we're looking for when we're analyzing domains. Something we're watching out for. So it's when is this function undefined? So f of x is undefined if x squared plus 3x minus 10 is equal to 0. So it's not so much if x is equal to 0. In fact, x equals 0 is just fine here because the denominator, when we plug in x equals 0, will be negative 10. But is there some other value of x that's going to cause a problem? And this is a quadratic equation that we can solve possibly by factoring. Let's see if factoring will work. And I think you can see x plus 5, x minus 2 is going to do it. So x plus 5 equals 0, or x minus 2 equals 0. So x is negative 5, or x equals 2. So these two numbers are not in the domain. So we want to imagine a real number line where, now I'll write the smaller one first. I'm just going to indicate negative 5 and 2 here. We're going to leave those out, but we're going to include all the numbers less than negative 5. We're going to include all the numbers in between, and we're going to include all the numbers greater. Now in words, the domain is all real numbers except x equals negative 5 and x equals 2. So you could say the domain in words in that way. If we're going to use interval notation, let's think about this number line picture. Because there are two holes, there are actually three pieces that we have to write down if we're going to use interval notation. We start at negative infinity with the parentheses, comma, negative 5 we got to leave out. So we put a parentheses. Then there's a second piece. So we have union for the second piece, which goes from negative 5 to 2, both in parentheses because they're left out. Then we have a hole, so we got to say union. And then we have our last piece, parentheses 2, infinity. So there's the mess of interval notation to express this fairly simple idea that we're just leaving out two numbers. But when you leave out those two numbers, you end up with three pieces, three intervals that form the domain of that function. So there's number 7. Okay, so number 8. So the kind of trouble, again, we look for is x in the denominator, and square root. And in this problem, we have both of these. And now the way I wrote this, we kind of have to cross paths here because the denominator's on top. So there are two different problems here, and we got to consider the effect of both of them. They're both going to contribute to our final statement of what the domain of this function is. It's like each trouble point makes us remove some numbers from the domain. We're going to think of it one step at a time. So let's just start out first. Let's look at the square root. So the square root of x plus 4, the expression inside the square root, has to be greater than or equal to 0. And so this inequality isn't too hard to solve. It's just x is greater than or equal to -4. So I start out thinking, okay, in my mind, we have this real number line, this x-axis. Here's 0, 2, 3, 4, 5, 6. So 1, 2, 3. Here's -4. So we start out thinking, okay, as far as the square root's concerned, the x-coordinates have to be greater than or equal to -4. I'm not done yet, because second, I have to look at the denominator. And the denominator is x minus 1. We want to know where that denominator is equal to 0. Not so much where x is equal to 0, where the denominator is equal to 0. The denominator is equal to 0 when x is equal to 1. So x equals 1 must be removed from the domain. We can't include x equals 1. So we sort of have this preliminary number line sketch up here, up above. But now that was based on the square root. But when we also look at the denominator, x equals 1 is right here. It's kind of like, I'm going to impose this here. It's like we got to put a hole there, right? An open circle. Because we got to remove that one point. So now we're ready to state what the domain of the function is, taking both these factors into account. I have two pieces, right? And here it's actually much easier to just, I wouldn't try to state this in words, I would just use interval notation. This is where interval notation is really handy. But I have to use two pieces of interval notation because I start at -4 and I move to the right and there's a hole. So the piece before the hole is square bracket -4 comma 1. I go all the way to 1, parentheses, because 1 is not included. A union symbol in between that and the next piece now. We start up again at 1 with the parentheses to infinity. And there's my interval notation way of expressing the domain of this function. X values less than -4 way over here, the trouble they cause is they would give me a square root of a negative, which we can't do. The trouble that 1 causes, it's not the square root problem, it would make the denominator 0. So there's two kinds of trouble, and we've eliminated any number that causes either one of those two kinds of trouble. So there's exercise 8, and we'll finish these up in a next segment.